quadratic function. So here's the first form of a quadratic function. This is in polynomial form. So as you can see, there is an a here, a b, and a c. Those are all real numbers. Another form is in factored form, which, as you can see, we call this otherwise also as the standard form of a parabola. So you can see that a here dictates the vertical stretching and the vertical shrinking of the parabola. H and k here, it's the vertex. So h is the x coordinate and k is the y coordinate of the vertex. So there are only two possible graph here. If a is positive, the parabola is opening upward, where the vertex it's the lowest point of the parabola. If you have a negative a, then the parabola is opening downward, where the vertex it's the highest point of the parabola. Okay. Now, aside from being the vertex, this is the horizontal shift also when you're looking at the h, and the k refers to the vertical shift. So when you say shift, that is the same as the translation. That's the same thing as the movement of the parabola. Okay, so when you say vertical shift, that's the y. So it's going up or down. When you say horizontal, it's the movement of the parabola that's going to the right or going to the left. So here's the axis of symmetry. So the parabola can be opening upward. So if a here is positive, if a is negative here, then the parabola is opening downward. We can only actually find the axis of symmetry when we know the vertex. So that's the key point here. Finding the vertex, it's the key solution to find the axis of symmetry. Okay, so let's have an example. Let's say you're given with f of x is equal to x squared plus 2x plus 1. The degree of the polynomial here is 2. So it means this is a parabola. And we call this form as polynomial form. Now in here, you cannot find the vertex by just looking at the equation. Unlike the standard form or the factored form of your f of x, you can find it. So we can transform the polynomial form here into standard form of the parabola, or we call this as factored form. So if you're going to do that, it's just going to apply your skill in factoring. So this is a perfect trinomial square. So that would be, the factored form would be x plus 1 times x plus 1. You can always check by looking at the inner terms. 1 times x is x, and the outer terms x times 1 is x. Adding this, it gives you the middle term, which is 2x. So that's exactly the factored form. And then we can put that into a power of 2 because they have the same binomial. Okay, and that would be our equation equivalent in standard form. So if you remember the one that I've shown you a while ago for the standard form of parabola, it's f of x is equal to a x minus h power of 2 plus k. So here, as you can see, this is our h here, and our formula is having a minus here, minus h, so it means that our h is a negative because that's a plus 1. So our vertex actually is at -1, comma. Now you don't have a k. K supposedly it's here. So we have a k here, which is missing. So that would be a 0. Okay. And looking at our a here is 1, which is a positive 1. So it means the parabola is opening upward. So when you draw the graph here, the parabola is opening upward, and the vertex actually is at -1, comma 0. So if you're going to be asked what's the axis of symmetry at this point, axis of symmetry here, the axis of symmetry is at x is equal to -1. X equals -1. It's the line that's passing through the vertex. That's the vertical line that's passing through the vertex. So this is our x equals 1, -1. X is equal to -1. So that's how you find the axis of symmetry. Okay. Another way to find the vertex here without transforming this into a standard form is by using the vertex formula. Okay. So on this side here, let's use the vertex formula. So vertex formula. Our h here is equal to -b over 2a. And we know what is our a and b here. So here's our a here. So, and then our b. So therefore, our b is a 2. So that's a -2 over 2. Our a is 1. So therefore, h is equal to a -2 divided by 2 times 1. That's a -1. And then looking for our k is f of h. Okay, and that is equivalent to f of -1. So you're just plugging in -1 to your equation. So that would be -1 power of 2 plus 2 times negative 1 plus 1. I'll get 1 here minus 2 plus 1. So k, I'll get 0. So as you can see, it gives you the same answer. Vertex is at negative 1 comma 0. So that's exactly the same as what we have here. Okay, so there are two solutions that you can do. If you can factor it, then you can actually have the standard form and find the vertex. And then if not, then use the vertex formula. Okay, but this example, you can do either of the two in order for you to find the vertex. Okay, let's take another example. Okay, so here's another example. So you have x squared minus 6x plus 7. So in here again, you cannot say that negative 6 is your h and k is your 7. So here again, you have to find the vertex by doing something. So there are two ways to solve this problem. You can actually do the completing of squares, or you can do the vertex formula. If you're thinking about factoring here, you cannot put this in standard form by using factoring. Okay, so there's no way for you to do that. So let's try by completing the square. Okay, so let's try that one. So f of x, this is by completing the square. So you have f of x here, and then let's move our 7 to the right side, and let's just put a space here and find the perfect square. And let's take negative 6. So the formula, if you remember the completing the square in the previous section, you're thinking about b over 2, and then you square that. So our b here is negative 6 over 2, and then you square. So that would be negative 6 divided by 2 is negative 3, and the negative 3 power of 2, it gives you a 9. So that 9 goes here. Since you're adding 9 to make the equation actually the same, or you're not changing the equation, you have to subtract 9 also here on the other side. The only goal for completing the square here is to make this into a standard form, so you can find your h and k. So that's the only purpose. Okay, so then the factor for this would be x minus 3 power of 2. So what you're looking for, it's the quotient here. That's -3. So that -3 here goes here. And then what is 7 minus 9? That's -2. Okay, so at this point, you know what's the vertex. So the vertex, this is our h here. So h would be this. Our k would be this one. So the answer would be a 3, comma, -2. So if we know our vertex, then we can graph this, and also we can find the axis of symmetry. So the axis of symmetry here, it's at x is equal to 3. X equals 3. So that's the line passing through the vertex. So that's the vertical line. X is equal to 3. Okay, so that's by completing the square. Now by using vertex formula, you can also find a vertex and solve for your h and k here. So our h here can be solved using the formula -b over 2a. And our b actually is -6 over 2. Our a is, let's label this. This is our b. Our a is 1. So a is 1 here. So the answer would be 6, because that's a negative times a -6. It's a 6 divided by 2. 2 times 1 is 2. So that would be a 3 for h. For k, that would be f of h. So that would be f of 3. So f of 3, that would be the value for x is 3. You plug that into the f of x. So you will have 3 power of 2 minus 6 times 3 plus 7. And you will get there 3 times 3 is 9. Minus 6 times 3, that's 18. So that's a -9. -9 plus 7, that would be a -2. So we have here 3 for h and -2 for k. So our answer would be, the vertex would be at 3, comma, -2. And that's exactly what we have here, and we have on the other solution. So the same vertex. So they are just the same vertex. Okay, and if you're asked to find axis of symmetry, that would be x is equal to 3 at this point. Okay, and that's how you do completing the square and using the vertex formula.